The sonar screen flickered at 10,847 meters. Inside the titanium pressure sphere of DSV limiting factor, the pilot leaned closer. A shape moved through the beam, long, deliberate, threading between the cold seeps of the Serena deep. It wasn't drifting, it was tracking. For 17 seconds, the return held steady, then folded back into the black. The dive log went quiet. No chatter on the comms. Just the soft hum of life support fans and the steady creak of a hull holding back 1,086 bars of pressure. When the submersible finally surfaced 2 days later, the science team requested that the relevant sonar file be quarantined pending review. That file, according to crew accounts, has never been publicly released. The Mariana Trench has always been the part of Earth we visit last. It curves for roughly 2,550 kilometers across the western Pacific, a slow scar where the Pacific Plate dives beneath the Philippine Plate, and at its lowest point, the Challenger Deep, it bottoms out near 10,994 meters below sea level. That number alone is hard to hold in the mind. Mount Everest, dropped into that hole, would still leave more than 2 kilometers of seawater above its peak. Sunlight stops working around 200 meters. Below 1,000, the ocean runs on chemistry and patience. Below 6,000, the Hadal Zone begins, named for Hades, and even that name feels generous. Humans first touched the bottom in 1960. Jacques Piccard and Don Walsh rode the bathyscaphe Trieste down for nearly 5 hours, sat on the seabed for 20 minutes, and saw what? Piccard described as a flatfish-like creature glide past the viewport. Marine biologists at the time doubted him. The pressure, they argued, should have ruptured any vertebrate eye. Decades later, when Jamstec's Keiko and then Woods Hole's Nereus mapped the trench in higher resolution, sightings of Hadal snailfish at 8,000 meters quietly confirmed that Piccard had probably been right all along. The lesson stuck with deep-sea researchers. The trench keeps embarrassing the people who think they've already finished cataloging it. Modern Hadal exploration runs on a small fleet. China's Xiaolong reached 7,062 meters in 2012. Their newer Fenduji, a full ocean depth submersible, has logged dives at Challenger Deep since 2020. Victor Vesovo's DSV limiting factor, built by Triton Submarines, completed the first repeatable crewed dives to the bottom during the 5 Deeps expedition. Add Schmidt Ocean Institute's autonomous and remotely operated vehicles, Jamstec's Shinkai program, and NOAA's Okino's Explorer mapping runs, and you have maybe a few dozen people in history who've actually looked through a window at full Hadal depth. Compared to the number who've stood on the moon, it's a startlingly small club. And that scarcity matters, because every dive that returns with something unexplained carries weight that 100 shallow water sightings never would. What the limiting factor crew described from that 2021 transit through the Serena Deep wasn't a creature in the dramatic sense. It was a sonar contact. Specifically, a sustained 38 kHz return that drifted laterally relative to the submersible at an estimated 1.2 meters per second, holding station for roughly 17 seconds before dissipating. The contact appeared at a slant range of 84 meters. The acoustic signature, according to a later technical summary circulated among Hadal researchers, did not match any of the standard biological echo profiles cataloged. From the trench, not the gas-filled swim bladders of mesopelagic fish, which don't exist at that depth anyway, and not the soft tissue signatures of holothurians or amphipods. Whatever produced the return was either large, dense, or shaped in a way the system couldn't classify. That alone would not be remarkable. Sonar returns get misread constantly. Marine snow, temperature gradients, even the wake of the submersible itself can produce ghost contacts. What turned this particular incident into something the team did not want to discuss publicly, according to 2 people who reviewed the log under a non-disclosure agreement, was a second factor. The contact's trajectory appeared to respond to the submersible's heading change. The pilot rotated the vehicle 6 degrees to port. Within 4 seconds, the sonar return shifted in a way consistent with maintaining relative bearing. In plain language, it seemed to turn with them. The Serena Deep is the second deepest pocket in the Mariana system, lying about 200 kilometers east of Challenger Deep, with a maximum sounded depth of approximately 10,809 meters. It was first identified clearly by NOAA bathymetric surveys in 1997 and named for the Spanish word for mermaid. Water temperature there sits between 1 and 4 degrees Celsius. Pressure exceeds 1,000 atmospheres. The bottom is a mixture of soft pelagic sediment and exposed bedrock from the subducting slab, dotted with serpentinite mud volcanoes that vent fluids enriched in methane and hydrogen. Those vents matter because they support chemosynthetic ecosystems that researchers have only begun to characterize. Microbial mats, tube worms in places no one expected. Whatever the sonar caught, it was operating inside a habitat we genuinely don't know the full inhabitants of. Dr. Alan Jamieson, founding director of the Minoru U at Deep Sea Research Center and one of the most experienced hydrobiologists working today, has been openly skeptical about sensational readings of trench data. Jamieson logged hundreds of hours of seabed footage during the 5 Deeps and Hades expeditions, and he's the researcher who formally described the Mariana snailfish Pseudoaperus suaire, found at 7,966 meters. When asked about anomalous sonar contacts in the trench during a 2022 interview with New Scientist, his answer was characteristically blunt. Most so-called anomalies, he said, are either acoustic artifacts from the submersible's own motion through stratified water layers, or large aggregations of small animals, amphipod swarms in particular, whose collective echo can mimic a single solid target. He cited the Hirondelia gigas amphipod, which can reach swarm densities high enough to register as a continuous biomass on echo sounders. His skepticism is not dismissal, it's discipline. And it's worth taking seriously before anyone leans into the easy story. Still, the discipline cuts both ways. Jamieson himself has documented Hadal snailfish surviving at depths once considered biologically impossible, and his team's traps have brought up amphipods carrying microplastics and even traces of military-era PCBs. Researchers believe the deepest fish ever filmed, a Pseudoaperus specimen caught on camera by a University of Western Australia and Tokyo University of Marine Science team in August 2022 at 8,336 meters in the Izuo-Ogasawara Trench, just north of the Marianas, sat right at what biochemists call the piezolite ceiling, the depth beyond which the protein-stabilizing compound trimelamine N-oxide can no longer offset hydrostatic pressure. Theoretically, no vertebrate should live below roughly 8,400 meters. Theoretically, the same word that kept Picard's flatfish out of the textbooks for 40 years. The acoustic question is where the analysis gets genuinely interesting. Sonar at Hadal depths behaves differently than at the surface. Sound speed in seawater increases with pressure and decreases with temperature. And at the trench floor, those two effects combine into a sharp positive sound speed gradient that bends acoustic beams in ways shallow water operators rarely see. Dr. Karen Haywood, an oceanographer at the University of East Anglia, has noted that signal interpretation in the Hadal zone requires recalibration against local profiles rather than reliance on standard models. A return that looks like a moving target might be a stationary feature, whose apparent position shifts as the sound channel flexes around it. One theory proposes that the Serena contact was exactly that, a thermaline lens or a localized methane plume from a nearby mud volcano, refracting the beam in a way that mimicked motion. Plausible. Possibly the right answer. But there's a competing interpretation, and it comes from biology rather than physics. Hadal megafauna remain genuinely undersampled. The deep-sea cusk eel Abyssobrotula galathea was hauled up from 8,370 meters in the Puerto Rico Trench in 1970 and remains the deepest documented fish capture, though imaging has since pushed the observed depth record deeper. Giant amphipods of the genus Alicella reach lengths exceeding 34 centimeters, enormous for their lineage. Researchers at Jamstake and the Woods Hole Oceanographic Institution have proposed, in peer-reviewed literature, that Hadal trenches likely host species not yet described, particularly large gelatinous predators whose bodies leave no fossil record and whose tissue dissolves before nets can recover intact specimens. Evidence suggests these animals exist. We just haven't caught one yet. A sonar return that doesn't match the catalog in a habitat whose catalog is admittedly incomplete sits in a category of evidence that's hard to file cleanly. Then there's the historical baggage, which complicates any conversation about strange acoustic readings in deep water. In 1997, NOAA Specific Marine Environmental Laboratory recorded an ultra-low-frequency event nicknamed the bloop. The signal was detected on hydrophones spaced more than 5,000 kilometers apart, suggesting a source of extraordinary acoustic power. Speculation ran wild for years. Some suggested a previously unknown marine animal larger than a blue whale. NOAA eventually attributed the bloop to icequakes from glacier calving in the Antarctic, and most acousticians accept that conclusion. Most. The episode lingers in deep ocean folklore because it demonstrated cleanly how little we understood our own listening data, even in the late 1990s. The Sirena contact lives in that same uncomfortable space, where every reasonable explanation has to coexist with a margin of honest ignorance. Crew accounts of the 2021 incident describe a specific moment after the sonar return faded. The pilot brought the external lights to full intensity and rotated the submersible through a slow 360-degree sweep. The cameras, recording in 4K at the time, caught only suspended particulate, the slow snowfall of organic debris that drifts perpetually toward the trench floor. No eyeshine, no movement. Whatever had been there, if anything had been there at all, did not present itself optically. The dive continued for another 40 minutes before ascent. The crew did not log a creature sighting in the formal report. They logged an unexplained acoustic contact, which is a much narrower and more defensible claim. The reason scientists involved have been careful with their language, careful enough, that the word silent gets used by people writing about it, is that the professional cost of overstating a Hadal observation is severe. Careers in deep-sea biology are short and grant-dependent. A researcher who claims a new megafaunal species without a recovered specimen, a clean image, or a peer-reviewable dataset can spend a decade being quietly excluded from future expeditions. Dr. Jameson has written about this dynamic directly, noting that the deep ocean attracts both rigorous scientists and credulous enthusiasts, and that the boundary between them is policed almost entirely through restraint. Saying less in Hadal research is how you keep your name on the next dive manifest. That restraint has a cost too. It means findings that don't fit existing models tend to sit in private conversations and unpublished logs rather than in the open literature. According to a 2023 review in Deep Sea Research Part 1, fewer than 15% of Hadal dive missions publish their full sensor datasets within 5 years of completion. Much of what we know about the trench, in other words, lives in expedition archives and on hard drives in oceanographic institutes, waiting for someone to have the time and funding to revisit it. The Sirena sonar file, whatever it actually shows, is one entry in a much larger queue. What this kind of incident appears to indicate, taken alongside the broader pattern of Hadal discovery over the past 2 decades, is that the trench is biologically richer and acoustically stranger than mid-20th century oceanography allowed for. The pressure-tolerant ceiling for vertebrates keeps getting revised downward, deeper. That is, the diversity of amphipod and isopod species at Hadal depths has roughly doubled in description since 2010. Chemosynthetic communities have been confirmed at multiple trench locations where surface-derived organic carbon was previously assumed to be the only energy source. Each of those revisions came from someone taking an unusual observation seriously enough to follow up on it, rather than dismissing it as artifact. Whether the Serena contact joins that list of vindicated anomalies, or quietly gets explained away as a sound speed gradient quirk depends on whether anyone returns to that exact location with better instruments. As of the most recent expedition schedules made public, no targeted return to the Serena Deep coordinates of the 2021 contact has been announced. There are larger implications worth holding on to. Roughly 80% of the ocean floor remains unmapped in detail finer than 5 kilometers per pixel. The Nippon Foundation GEBC Seabed 2030 project, which aims to produce a complete high-resolution bathymetric map by the end of this decade, has steadily moved that number, but the Hadal zones, the trenches deeper than 6,000 meters, remain the least surveyed habitats on the planet. Less than 1% of Hadal habitat has been visually inspected. By comparison, we have higher resolution surface maps of Mars, the Moon, and Venus than we do of the deepest reaches of our own seafloor. Researchers believe this is the single largest gap in Earth system knowledge that's actually fixable with current technology. The broader connection runs into climate, geopolitics, and even mineral economics. Deep-sea mining interests have begun targeting polymetallic nodules in the Clarion-Clipperton zone of the Pacific, and while that zone sits at abyssal rather than Hadal depth, the regulatory framework for any seabed activity below 6,000 meters remains thin. The International Seabed Authority has issued exploration contracts, but no commercial extraction permits at Hadal depth, and Dr. Jamieson and others have argued forcefully that we shouldn't commit to industrial disturbance of an environment we haven't even finished cataloging. A creature or an acoustic signature that doesn't match anything in the existing taxonomic record is exactly the kind of finding that should slow the conversation down. Once a Hadal ecosystem is disturbed, recovery timescales based on sediment community studies appear to run in the centuries, possibly longer. There's also a quieter implication, one closer to the original moment in the pressure sphere at 10,847 meters. The crew of the limiting factor that day were experienced people, trained operators. They saw something they couldn't classify, and they responded by gathering data rather than telling a story. That restraint is the part worth remembering. Whatever future expeditions confirm or refute about the Serena contact, the methodology, record, archive, hold the claim loosely, is the same methodology that has slowly, steadily widened our understanding of what actually lives in the deepest water on this planet. So here's where the evidence sits. In June 2021, during a Caladan oceanic expedition through the Serena Deep, the DSV limiting factor recorded a sustained 38 kHz sonar contact at a slant range of 84 meters, holding station for roughly 17 seconds and appearing to track the submersible's heading change. The acoustic signature did not match cataloged Hadal biological returns. Optical confirmation was not obtained. The crew filed the contact as unexplained rather than as a creature sighting. Dr. Allen, Jamieson, and other Hadal specialists have offered plausible non-biological explanations: acoustic refraction in stratified water, amphipod swarm density, instrument artifact, and those explanations may well be correct. One theory proposes a mud volcano methane plume. Another points to an undescribed gelatinous megafauna species, consistent with patterns researchers have flagged for years. What's unknown is larger than what's known. We don't have a recovered specimen. We don't have visual footage of whatever produced the return. We don't have a follow-up dive to the same coordinates. We don't have a published peer-reviewed write-up of the full dataset. The Serena contact remains, for now, One entry in a long list of Hadal observations that the field has decided to hold quietly rather than overinterpret. Maybe the next expedition resolves it cleanly. Maybe it joins Picard's flatfish in the slow, steady record of the trench teaching. US, again, that we finished cataloging it too soon. Either way, the deepest place on Earth seems content to keep its own time, and to release its answers only when we've built the patience to actually receive them.